Yeah, I'm recording. Hey everybody, this is Eric Jackson, cybersecurity nerd type and occasional college professor. Uh, I was helping out a student recently, and they asked me about OWASP, or specifically OWASP WebGoat, which is an intentionally designed vulnerable website. So you can download this vulnerable website or run it, and it has lessons built into it about various hacker techniques that are used in the wild. One of the ones I was asked about was actually the first assignment, A1, inside of WebGoat, which was session hijacking. Um, I was asked about it, and I figured I would take a look at it. Not teaching that class at the time, but I've never used WebGoat. Kind of pre or post dates me by the time that I was done with hacking stuff. WebGoat hadn't been developed yet. Uh, and then part of the lab, as we looked around, because I'd never seen this before, was using Burp Suite, which is something I've also never used, really. I just kind of did it manually because it was, again, when I was doing this, it was kind of predated things like Burp Suite and those kind of tools. So I went through a kind of long and arduous process to go through this lab or this WebGoat exercise, and I wanted to show everybody kind of how it worked and some pitfalls of penetration testing and being clever and trying to be smart. A lot of things I did that I tell people not to do. So I'm gonna go through what I found and why it works sometimes, why it doesn't work sometimes, and a lot of the idiosyncrasies around this particular attack. All right. So inside of Kali, which I have a fresh Kali install here. Well, it's not fresh, but it's new. I downloaded it a couple days ago. I went ahead and blew away WebGoat and everything I've done so that we can kind of start from scratch together and see the journey, so to speak. So if you've downloaded WebGoat, like I recommend you make your life easier if you're going to go through these labs, is download Kali, get a Kali working VM, and then download WebGoat. Which I've done here. Just the distributable binaries, not Docker or anything fancy. You can certainly do that, but if you're just looking to do this quick and fast, this is the way to do it. So, as you can see, I've got the jar file here already extracted. I downloaded it and then extracted it, and now I'm just going to open I got to close these command prompts. I'm going to open a fresh command prompt. I'm going to change directory, cd to downloads, and inside of here, I should have WebGoat. I'm going to see what its properties look like. I've already set to executable. If it's not, if you just download it, you're going to type chmod plus x webgoat blah 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 blah. Bam, there you go. Now I'm going to say /, which is a Linux thing to say this is how you run the local thing. And so /, webgoat.jar, which is the whole application written in Java. And I'm going to start it up. Now, this is where things immediately got weird for me and could get weird for you, depending on how you do this. So, you can see I can go to 127.0.0.1 80.80 WebGoat, and that will get me to the vulnerable application. We're going to start a new session. I'm going to go 127.0.0.80, 80, etc. To WebGoat. I'm going to run that up. And here it is. I'm going to register as a new user. I'm going to call myself Jackson. And the password will be password. This is a vulnerable app, so bad password's not really going to matter. I'm going to create the terms and conditions, which I'm sure I've read closely, and then proceed on. All right. So I am here, and I'm looking at A1 hijack a session. This is the lesson that a student asked me about, and I was like, oh, this will be easy, and then it ended up taking me quite a while to sort out on my own. And I think kind of part of that is because it's not being super clear here. It says, in this lesson, we're trying to predict the hijack cookie value. The hijack cookie is used to differentiate authenticated and anonymous users of WebGoat. So if I type in a username, well, actually, I guess we should look at this first. If I hit F12, which is the debugger for Firefox. If I hit F12, I get this up here, which shows my cookie values. You can see I have a JSession ID with a value in it, and that's all that's being stored as a cookie. You can see that over here, cookies, blah, blah, blah. So if I'm going to put in a username of A password of A, because it doesn't matter, I'm going to hit enter, and you'll see now I have a hijack cookie. value over here. And that's the one that we want to eventually hijack, I guess. And so if I hit access again, you'll notice if you just look down here at this, and it may be hard to see on the screen, the cookie ends in 123. So I'm going to hit access again. Oops, I'm sorry, I have to delete that cookie. So I'm going to delete the cookie. And then I'm going to hit access again. Remember, the old one ended 123. I hit access again. It ends in 278. If I delete it again, access it again, 194. And on and on. I can just keep deleting this thing and access again, 807. Just keeps issuing me a new hijack session cookie, or a hijack cookie every time I delete the cookie and then try to access it again. It's basically giving me that cookie telling me that I do not have access. I'm an anonymous user of this application, whatever that is. In order to get access to that application, I would need a cookie that's known good. And so here's this is where it gets weird. So what we need to do, if you look at the hints here, it says check the hijack cookie value and think about its format. Well, if you look at this value here, I mean, you can think about the format all you want. It's not necessarily the most obvious thing, especially when you have one of them. So looking at this cookie here, it doesn't really appear to be anything too special. Let's delete the hijack cookie, access it again, and then we'll go in there and copy that value, and we'll paste it into here as well. So as you can see here, the cookies, this first number here is a line number, so that 1 and that 2 are line numbers. But otherwise, 269, 182, blah, 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 they're all the same except for 31, 32. And if you look at this, they're the same up to here. Up to here. So let's paste another one in and see if the similarities stick. So we'll delete the hijack cookie, we'll access it again. We'll go in here, copy the value, go in here, and paste it in. So if we look, we have 31, 32, 34. And then if you look here, it's the same from here to here. So 5-1, 5-1, 5-1. And then we have 2-8, 4, 2-4. Exactly. So there are changes in the data from one to the next. But you'll notice it's 31, 32, and 34. That's all that's changed on these. The 269, etc., all the way up to here is the same. Let's go get another one. So we're going to go here, delete this hijack cookie value. We'll access it again. Go in here, copy the value. Go over here, paste it in, and we've got a 36. So 31, 32, 34, and 36. Over here, this number is still changing, kind of how we expect it to. And let's go delete it again, and we're going to access again, and we're going to go in here, and this number will be 37. So we got 37. From here, this is kind of like tickling myself. I know what we're looking for, so it becomes obvious. But if you were to look at this, as we've described, you can see that 31, 32, 34, 36, 37... what do you bet the next one will be 38, or probably, it'd probably be 38, it could be 39. So let's delete it, access it, go in here, grab it again, and paste it in, and there you go, it's a 38. So we can kind of see a pattern here, and as far as we can tell, that probably holds true. There's a couple ways to check this using tools, and so this is where I got clever and things got weird. Was I started to use tools, and I started to write my own tools because I don't know how to use modern tools because I'm an old man. I don't recommend people do that. Tutorials are good, and I should have gone that way. But here's what I ended up with, something like this, and I ended up writing a bunch of tools to solve the problem. Before we go into that, let's look at one way to get a larger sample size here, right? So 31, 32, 34, 36, 37, 38. If I do the next one, it's probably 39, next one's 40, but we don't know if it's really like that forever. We just know it works for 6 examples that I've done so far, plus a couple I didn't copy and paste. So this is where something like Burp Suite can come in and be useful. So let's go over to Web Application Analysis inside of Kali, and we'll open up Burp Suite here. My burp suite has been updated. You might get some warnings about it being out of date, or that it's a trial version, or that it's more than 3 months old. If that's the case, update your Linux distribution, um, or Google for it to figure out how. So we are here now. This is Burp Suite. Burp Suite is basically just a proxy. All of the network communication being spawned by Burp Suite goes through a bunch of stuff that we can stop it, analyze it, mess with it, change it before it actually goes to the internet. So it's kind of like this debug mode back here that I'm using in Firefox on super steroids. So if I go into the proxy and I'm going to open a browser, this now gives me a browser that is browsing through the proxy there for Burp Suite. So I'm going to go into WebGoat again, like this. I'm going to log in, which was Jackson, and password. All right, we're going to hijack a session. There we go. Click on 2. We're going to put in A and A, which, by the way, obviously this could be A and B. It doesn't matter what you put in there. We just want that cookie value. I'm going to hit access. Sorry, the solution's not correct. Please try again. Great. And then I'm going to go to Burp Suite and see what's going on. So if I go to proxy and I hit HTTP history, you can see these are all the things that have been happening in the background while I was browsing the website. When I click on login, it posts this data here on the left, and it returns this data here on the right. You can see here when I did the post, I did not have a hijack session cookie. Once I did the post, it gave me back a hijack session cookie by setting it right here. And now if you go further down, you'll see that all of my requests from here on out have a hijack session cookie. So if I go log in here and I go down here and I send a repeater, and I go to the repeater, you'll see this is the thing that we just saw. I was just posting with this data. And so if I hit send, I get a hijack cookie, right? Because when I sent it, there is no hijack cookie. So when I send, it tries to give me back a hijack cookie. You'll see this one ends in 4.0, which kind of falls in line with our previous findings where it was 38. So now we're looking at 40. We're going to refresh that again, and it'll be 41 here. And just watch that number. It'll be 42, 43, 44, 45, 47. So we skip 46, and on. So we know this is kind of working. We know that that's the way it's supposed to look. So now we're going to send this to the sequencer. And you can see, because the sequencer knows that that response is going to be the hijack cookie, it automatically assumes that's what we want to sequence, which means we're going to get a big sample of these very quickly to see what it really looks like if there's a bunch of them. So it's the exact same thing as me smashing this send button back here, but it does it for me hundreds and thousands of times. So I'm going to hit start live capture. While this is capturing, an item of note, if you do this in the real world, you point this at something that is real, like, you know, a real secure enclave, you're going to make people angry. They will see this, it will be loud, and they will, if you're committing crimes, they might come for you. So be very careful about using tools like this. We can do this because it's WebGoat. It's right on my current virtual machine. It belongs to me. I can do whatever I want to, and I can beat it any way I see fit. So we're going to bludgeon it with these and collect as many tokens as we want, which I've got. We're going to stop here around 2,000 tokens. So I'm going to stop it. I'm just going to say, are you sure you want to stop it? I'm going to say, yeah. I'm going to save the tokens. And I'm going to call it, let's just call it tokens.text. All right. So I've saved those, and now in my downloads directory, which is around here somewhere, in my downloads directory, I will have a tokens.txt file. If I open it up, there they are. The problem with this is that they're not totally going to be in order. They'll be close to an order, but you can see like a 50 there because Burp Suite is multi-threaded. So as it's, I think in this case it does 4 requests at a time. So as they come back, it lists them. So they're going to be out of order. We don't really want that because we're trying to look for a pattern. So this is Linux. Linux has a lot of cool features, one of which is a command called sort. So we're going to go to downloads again from the command line. And in here I have tokens.txt. I'm going to sort tokens.txt. And we'll just output it to a file called tokens sorted.txt. Do that, and then we will open that in our text editor just to make sure it looks right. And there you go. Okay. So, if you look at this, we can see 48, 50, 51, 52, 54, 55, 57, 58, 59, 60, 61, and on and on and on and on and on and on. Effectively, if you're looking at these first, however many numbers this is, you're going to see that the second number here is the one that's changing, and of course the third digit, the hundreds place, will change, or I'm sorry, the thousands place will change as the numbers iterate up. So we have a pattern. That's the point. Whatever you want to think about it, however you want to think about it, we have a pattern. There's a bit of a cheat here when it comes to this second number. So the first number, let's call that the session ID, as in this is the thing that you are given that is a unique number to you. This here is something you would recognize if you know it, and if you don't know it, you won't recognize it. It's what's called a Unix timestamp. For some reason, Google will tell you why. Back in the 70s, 80s, when Unix was coming into its own, in order to keep time, what they did was they picked an arbitrary date, which was January 1st, 1970, and they just add seconds to it. So it's in seconds, or it's how many seconds have passed since January 1st, 1970. That's all it is. So if you were to take this number, 170, blah, 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 and add that to January 1st, 1970, you would get today's date and the seconds and minutes and all that. So it's a big number that really, honestly, that 17090 kind of helps us to remember that that's a Linux time, or 170. But ultimately, that's a Linux timestamp. And when you look at it, you can see that they are sequential. When you look at this, it's 434, 487, 512, 566, 614. These numbers never go down. So with that, we know now that we have a number that it wants to be sequential. 77, 79, 81, 82, 84, 86, but it's not perfectly sequential. We know that this is a timestamp because we know it's a timestamp. It looks like one. But even if you don't know it's a timestamp, you can still tell that the number never goes down, which means it's going up constantly. You could infer time from that, or at least some serialized number that's always going to go up. So with that, if you know it's going up and we have one missing, what does that tell us? Well, this is a web server. Web servers have multiple users. If I'm requesting a cookie and the cookie is serialized, and I get 77, then that means most likely 77 was the next one. If I request it again and it's 79, that means most likely somebody else got 78. That's the way it works. We know it's handing them out sequentially. So we know that there is a cookie out there that looks remarkably similar to that one, but it's going to be 78. We assume that. The one thing we don't know is what this time code is going to be, but we can kind of guess, right? We know it's going to be 1709051. If you look down, and 68 and 3, right? So if we look at that, we know that because the number's always going up, and we know the number here and here are the same, that we know that this number here has to be between 434 and 487. So for the sake of it, we'll just say 434 and 487. For math nerds, this is inclusive. It's just the way the program is written. So it could be 434 and it can be 487. They could share the same ID or the same timestamp because of the fact that they have a different session ID. So this is our theoretical right here. We know, or we suspect, that there is a session ID that's been issued that looks just like this, and we want to steal somebody else's session ID. That's what it's going to be. We know it's going to look like that. And with that, you almost have a whole solution, right? If I wanted to, there is only so many possibilities here. 43 possibilities of the cookie, right? It could be 435, 436, 437, all the way up to 487. Um, so I need to test that. There's a bunch of different ways to do it. Let's do it with Burp Suite first and see if we get any results. Hello everybody, Eric Jackson here, future Eric, as I'm editing this video, which I don't do often, but I was going through and editing this video because everything starts to go weird from this point on. Burp Suite and I are not getting along, and I believe Burp Suite, WebGoat, and Callie are not getting along. So what I'm showing you is right in the sense of this is how you do it. It's wrong in the sense of it won't work. As we get to the end, I'll show you how I end up doing it myself. And you might see some weird cuts going through here as I'm trying to get it to make more sense and actually work the way it's supposed to. So inside of Burp Suite, we already have the sequencer, which we just ran and got us all these token values. So next we have the... hold on, close out all of my sequencers here. So now we're back here to Burp Suite. This is the repeater we just ran. We ran the sequencer to get this list. And now we have what we suspect is a decent cookie. 470, or it's number 78, and it's somewhere between 434 and 487 over here. So let's take this packet here. Hold please, I'm going to go back to the proxy. And let's find a login session that has both the cookie and the session ID in it. So we're going to go over to our browser. We're going to access it again. And we should, in our history now, have a hijack session with the cookie in it over here. So see, we just ran that again. There it is. So we have the hijack cookie session ID. So what we want to do, if you think about it, is we just want to send this packet over and over again to the server, but with different values in this hijack cookie, right? This session ID is our session ID. That's important. We need to have that. This part is the one that we can change. So if we were to somehow just say, hey, let's make this number look like the one we have in our notepad right now, then we would be good to go. So let's take this and send it to the intruder. Let's see if I picked the right packet. I did. So here we go. So this is the hijack cookie. You see over here where it is highlighting this. We're going to delete that and that because we're going to change this cookie value to what we have in our notepad. So let's go over to our notepad. We've got this one here that we suspect is the right one. If you remember, I'll just grab the whole thing so we can work with it over there in a way that makes sense. So we're going over here and we're going to delete the hijack cookie value and replace it with that one that we have there. Now, we know 78 is right. We know this is the one we want to test anyway. We know that there was a gap between 77 and 79, so we're going to test 78. Now we have 434 over here, 683, 434 to 487, right? So let's just say 434, highlight that, and then we're going to use some burp magic here. We're going to add these markers. I don't know what you call those. They're like double S weirdness. I'm sure they have a very formal name. So you click on that there, and then we're going to go to payloads. So we are going to have a list of numbers, right? So what we want to do is we want to replace in this position that 434 with 435, 436, and on and on and on. So we know it's 434, or we know we're starting at 434, so we're going to start at 430. Remember, turn on your number lock, kid. 434, and we're going to go through to the number that is not remembering. There we go, 487. 487. We're going to step one time per packet. The minimum integer digits is 3. That's not going to matter here, but that's just to make sure that if you had the number 1, it would say 001, not 1, because it'll mess everything up. So I'm saying 3 just because it's best practice, let's say. And we're going to start the attack. And it's going to warn us this is throttled because they want you to pay for this. Burp Suite is not free for commercial use, and this intruder component is their bread and butter. They want you to pay money for that. So as we send these out, if you look at our request, you can see that I have a hijack session cookie 78 and 34. If I look at the next one, 434. If I look at the next one, 78, 434. The next one is 78, 435. The next one is 78, 436. And it'll just keep trying. The way this lab works, if you look at the response, it will tell you straight away, sorry, the solution is not correct, keep trying. So we're going to go through each solution, of which there are 54 running down here, you can see, and we're going to go through and check. And I have had very bad luck with Burp Suite working on this, so we're going to see if we can get to work. And response, sorry, solution is not correct, not correct, not correct, not correct, not correct, not correct, and not correct. Still going. We got two more, 53 and 54. Okay, so it didn't work. Don't know why yet. Let's go figure out why. So we're suspect that there is, this doesn't mean we're wrong. There's two things that could happen here. Well, there's a bunch of things, but let's say that there's two that we care about in the real world. One, the session ID may no longer be valid. And if that's the case, we would just go look through this these tokens back here and find another missing one. We know we're missing 83 right there, A2 and A2 and A4, which means we have a gap between A2 and A4 of 83, right? So it's possible that session ID is not valid, but let's go double check a couple things before we get too into the weeds about it. So when you look at how we were sending this, let's go ahead and close the intruder. Do not keep because it didn't do anything. If we go look at the positions and we look at our JSession ID and our hijack cookie value, we know the hijack cookie value is what we want it to be. Let's just double check that I didn't trim any text incorrectly. That is 86. Well, here, I'll just copy and paste a value in. We just want to make sure that this looks like it's supposed to look without the S's and the double S's in it. Okay, so yeah, we put in the right value, so that's good. And I know watching somebody troubleshoot is like watching paint dry, but we do want to make sure that we've done everything as right as we can. So the next thing is that session ID. So that is given to us by WebGoat, and that is a value that if we mess that up, it won't work, no matter what we do with this hijack cookie value over here. So we do want to make sure it's the right one. So if we go back to our Chrome, all right, remember when I told you everything was going to go wrong at some point? This is when everything went wrong. When I went to go launch developer mode in Chrome, it exploded. The Kali box failed entirely. I had to restart the box, which caused it to, I had to restart WebGoat, which caused the session IDs to all die, which means I had to start over, which is all fine and good. It still doesn't work doing it the way that we were doing it through Burp. If you watch this and you're a Burp expert, let me know what I did wrong. I'm not sure what it is. So instead, I'm going to go with what I ended up doing and how I ended up doing it. Remember, as we go through this, the principle's still the same. We just need to figure out a missing session ID and generate all the possible numbers it could be and keep pinging the server until it lets us in effectively. So I'm going to go through that process and show you guys how it works and how I did it. It's important to know in security the how barely matters, it's the what. What we need to do here is pass the correct cookie value to the machine, or I'm sorry, to WebGoat, to the web server. We need to figure out how to do that. That's our job. And how you choose to do it is going to be what works for you if it works. If Burp Suite works for you, awesome. Like I said, I'm kind of an old guy. It's new to me. I just never used it. I use a combination of curl and Visual Basic Scripting and a couple other things that you should never do. It's because it's fast and easy for me. My workflow works. That's my how for security. But the what will always be the same. So let's go through that and how I did it. This is my script that I use to generate this. I have token list over here, right? I just have 2 tokens. What my script does is pretty simple, right? It looks at this number. If there's a difference between these numbers, it identifies it and then generates a cookie a hijack cookie that would look like this, and then it would identify the difference between here. And so it's just going to generate a series of them that looks like that, all the way up to 1670 or whatever, 01670. So that's what it would look like when it generates all the keys in that particular case, because it's given those two keys. So that's all it does. It looks at that file, it generates the session keys, but it does it using, it generates the hijack cookies. It does that using, it just creates a list of commands that I can run in Linux using curl. So I'll talk about curl real quick. Okay, so I'm going to go ahead and show how I would have done this, or how I end up doing it without using Burp Suite. It's not to say that Burp Suite is wrong. It's just not what I wanted to do. So I'm going to open up command prompt, just like before. I'm going to reset this lesson in WebGoat because we've already beaten it differently. So we are going to try to reset the lesson. There we go. Lesson's reset. So we go here. There's nothing. If I go and look at my cookies, I have a hijack cookie. I have a session ID. So I'm going to delete my hijack cookie and be given a new one. This is just a fresh one, so I know I'm dealing with a fresh one. So I have written this script. The script makes my life a lot easier, so I'm going to go over to the script and put in my JSession ID, which may still be the same JSession ID. My JSession ID is in my code now, and I'm going to go generate some hijack cookies until I get what I want. So what I'm looking for is one of those gaps, right? So I'm going to delete the hijack cookie. Well, actually, I don't really need to, do I? Let's just do it like this. So let's talk about curl real fast. So I have curl, and you can see I've been using curl a lot. So I'm going to duplicate what Burp Suite was doing with a post, right? So -x mode is post, and then we're going to set a cookie, which you can see I've already done a lot of this. Rather than reinventing the wheel, I'm just going to backspace until I get to the right place. So what we're trying to do is, first we want to get a hold of a hijack cookie, a fresh hijack cookie, but I do need the right session ID. So let's grab that session ID right here. I'm going to copy it, and we'll paste it in. All right, there's our session ID. We are not going to give it a cookie. We're not going to give a hijack cookie, rather. And we're going to send it some data of username equals Jackson, and password equals password, and it's going to go to http://127.0.0.1/webgoat/ whatever that is. I'll have to remember. Hold on. Please hold while I look this up. All right. I was looking for an easy way to find this URL. I found it through Wireshark. I don't have the capture. I have it written down on this window. You can see this is the URL, so I'm just going to grab that. And we're going to paste this in here. Right click, paste selection, and we're going to hit enter. All right, cool. So you can see that worked in the sense of we just sent the same information that Burp was sending, that the browser sends, and it came back and said, sorry, the solution is not correct. Please try again. So we know that that's not right. We don't have a hijack cookie in that response. If we turn on verbose with -v, you'll see that it does indeed give us a hijack cookie right there. There's 50. So let's do it again. And there's 51. And again, 52. And again, 53. And again, 54. 55. 56. 57. 59. All right, cool. So we know there's a gap of 58, so I'm going to grab 59, which is the last possible position. And I'm going to put it in my code, well, more specifically in my list of tokens here. I'll put that as the first token. I'm sorry, that will be the last token. And then I'll grab the one above it. So that was 59. I'll grab 57. And go put that into our token file. We'll put it in front because it's in order. So 57, 59. You can see a gap of 58. Now, my code doesn't do anything particularly scientific. Before we get real crazy about the code, let's go look at this curl command one last time. So when I am in Kali, let's go look at that curl command. So here we are. Yep, this is it. So here's the command. So we have curl, which is a command, X, which I don't remember distinctly what that is. I'll put it on screen here somewhere. And we're going to do a post. I believe that's what it is. It's just a command we're sending. There's going to be a post. We're sending a header. That's what the -h is with this cookie data. And we have the data we're sending, which is our username and password, which is Jackson and password. And this is the URL we're sending it to. If we wanted to incorporate our newly found cookies in there, our hijack session cookies, we can just put in there with a semicolon, basically. So we just put in right here at the end of the JSession ID, we'll do a semicolon, and we'll set a hijack underscore cookie, and we'll set equal to, and I believe I have one on the clipboard, so just right click, paste selection. That is not it. I was wrong. So let's go grab ourselves a cookie from up here. Sorry, I keep calling cookies. Hijack cookie. And we're going to, again, paste selection. And we're going to hit enter. And we're going to take out the verbose just to make sure that we get a response. We do. So things to notice, if I put in bad values here, you may not get a response. Let's take the O out of there. No response. Likewise, if I put in a bad, well, if I put a bad hijack cookie, nothing happened. If I take out like the command here, because it's expecting this data, you'll get an error. So what we want is just this looking right with the correct identifier, and there you go. So that's what we want it to look like. That is, if we just had that and where this cookie is, we could just create however many commands we need, each one trying to guess that value, then we'd be done, and that's what my script does. So when I go over to this VBS script called URL gen, I save it, and I open a command prompt and run it. C script URL gen.vbs. URL gen looks for token lists. I don't need to feed it that. And if I hit enter, you'll see it generates lots and lots of curl commands. Just they look, if you notice, exactly like the ones that we just had in Kali. The only difference is it's going to change this hijack cookie. See 58, it's going to be 19, and then 20, 18, 17, etc. And it just tries every variation thereof. And then it takes the output and it dumps it into a directory called output with the name of the hijack cookie, out.txt. I'll show you why in a second. Basically, we just search all that output for the correct response. So I have that now. It is... I'm going to send that to out.txt and open out.txt in Notepad. I'm going to delete those first 3 lines, grab all of this with copy, go back to Kali, open up a text editor, in Kali it's mousepad. I'm going to paste that file in, and this will have 866 lines, 865 lines, so 865 guesses it'll make. Remember, when we did the intruder through Burp Suite, it was throttled, so it was pretty slow. 50 guesses took about a minute, something like that. We'll see how fast Error 65 is using my custom tool here. Well, custom tool, just a just a list of commands. We'll call it out.sh. I'm saving in that same downloads directory. Now, Linux has an idiosyncrasy if you're not aware of it. There's no such thing as an exe file. Any file can be executable or no file can be executable. It's up to you. So when I list this, you'll see that there is R dashes, RW dashes, etc. There's no X's. That means the file can't be executed. You'll see the WebGoat executable we've been using has X's on it. That's why it's allowed to execute. So let's add the ability to execute to out.sh by saying chmod plus x out.sh. And that's it. If you look at, you see in the background of this window here, here is the stuff. It's just going to start guessing all the different versions. So let's see if we get any luck with this. Remember, it's 865 commands, 55 commands at burp took like 5 minutes. And I didn't create an output directory, so it failed. So let's create an output directory and run that again. All right, 865 guesses. Each one of these is a guess. Now, while that's running, I'll open the downloads directory visually so we can see it. Here's output. You can see it's just dumping files in there, and it's done running. So we're going to grep, which is search for text. Use the CONG because the correct response will say congratulations in it. So we're just going to look for the word congrats or CONG in the output directory in any file, and we're going to run it. It did not work. Now, there's a lot of reasons that can fail and not work. The number one being that the session ID went away. So as I've seen here explaining this to y'all, I'm taking my time, and the session IDs will eventually fade out. And in the real world, it would mean that like whoever had the session ID logged out. They don't have it anymore. It doesn't exist anymore, so it's not valid. So what I'm going to do is I'm going to generate some more and see if we can't get it to work. So I'm going to pause this so you don't watch me keep trying. I'm going to generate some more keys or some more hijack cookies and find some more gaps, and then I'm going to run them, and then I'll test them, and I'll just keep doing this until I get it to work. All right, last interruption on the video. As I went through this, I had a bunch of problems, some of which were self-inflicted, where I wasn't passing around the JSession ID the right way, some of which was WebGoat wasn't acting right. I'm going to pick up right where I restarted WebGoat and went from there. I got it to work, and it works as expected. I have a feeling that WebGoat may be slightly buggy, because once you've done it once, it doesn't like you doing it again all the time. So this is the rest of the process through there, and then I'll close it out with a little bit of explanation. All right, so I'm going to come at this completely from scratch as though I'm doing it for the first time. So first thing we're going to need is that JSession ID. There it is. I'm going to grab that. I'm going to copy it. I'm going to go up to one of my other Kali windows, and I'm going to find a curl command. There's one there. I'm going to replace my JSession ID in there. Just a moment. JSession ID, Control Shift Insert, Control Shift V. There we go. And hit enter. And I got back a hijack cookie right there. So let's start grabbing some hijack cookies. That was 30, 31, 32, 33, 4, 35. 36, 38. All right, so we got 38. I'm going to grab that selection and take that to my token list. And then do that. And that was 38, so I need 36. Whoa. 36 is here. Grab that here and paste. All right, I've got my two tokens, 36 and 38. My URL gen. Let me make sure I have the correct session ID in there, which I'm sure I don't. Let's go grab this from here will be fine. I had problems with this copy and pasting correctly. All right, and back to here, we're going to paste in our JSession ID. I'm going to run my code and make sure that that kind of looks right. So we've got JSession ID MB5, and the token is 37, which I believe is right, 36, 38, so the token is correct. Let's grab all of this text and take it back to Linux with us. Right. Linux, and we're going to open up our text program. We're going to open up out.sh in the downloads folder. Ignore the stuff that's already in here. That was from earlier. Let's see how my guesses we end up with. 866. Make sure that kind of looks right. That cookie is MB5. The session ID is 37. There's our JSession ID. Start with MB5. So that looks like it's right. We're going to save it. We're going to go up to a command prompt. We're going to run ./out.sh. And we're going to open our other Kali instance. And we're going to use grep to look at output. And there it is. That is the victory. Each one of these files inside of our directory reflects what was returned to the terminal. So if I go into output and I pull up any one of these files, you'll see where it says lesson completed, the solution is not correct, blah, blah. This is the file name itself, is the name of the session ID followed by the timestamp and then out.txt. So it tells us which one was what, and according to this, it would be 93774 out. So let's just open that file right there. Selection, I'm just going to do it through the command prompt, mouse pad. That's where I can type. And we're just going to paste from selection. And there you go. Now you can see this is the file, so you completely, successfully complete the assignment. And this was the correct session ID, 37-1709-070-236-874. And then finally, if we go look at our browser, you'll see that the hijack session is green now. It's complete. We finished it. So, that is WebGoat. That is penetration testing. And the thing I hate about this exercise is that it's not intensely clear what you're supposed to do. The results aren't reliable. The thing I love about this exercise is that that's how hacking is. The results generally aren't reliable. Doesn't always work. There's a lot of things that can go wrong. The other thing I like about this is, and if there's anything you take away from this, it's we knew what we had to do pretty quickly. It was how we did it that became troublesome or hard or the challenge. You saw that I was using Visual Basic Script, which is an ancient forbidden language that nobody uses anymore, but I know it by heart, so that's what I used. I could have done it in Python, which I probably should have done in Python. Very talented people in Linux can do it in Bash. And of course, if you're feeling fancy, you could just do it manually. You could use Excel to increment the numbers and then generate curl commands that way. There's a million ways to do it. The how is up to you. What we wanted to do was the objective, and we got that pretty quickly. So how we did it ended up working. We got through the result. So I hope this helps. This WebGoat thing is difficult. It is not an easy assignment for somebody just starting into some sort of penetration testing or computer security career field. So hopefully this helps you understand why we did what we did and how we got there, how it worked, but most specifically what we were trying to do and how we succeeded in doing it. Thank you, everybody. Have a great time, and hope you have a great week. If you have any questions, as always, email me, comment, because this will be on a YouTube video. Do whatever you want to do, and I'll try to get in touch with you and respond to your questions. Thank you.